If we run factor analysis in EMOS, covariance based SEM, it will run model like this. You can see in front of us. Independent variable with 4 items and dependent variable with 4 items, and 4 error terms are here. If you see E1, E2, E3 and E4. This is how we supposed to run, but many people when they run through EMOS, they usually do two things. Initially they start like that, then they start modifications. Double-headed arrow here, double-headed arrow here, double-headed arrow here. This is one modification. The second modification is they delete items. More items we delete, chi-square will be increased and degree of freedom ultimately will be improved. But we cannot keep on deleting items until we don't have any items left. That's a problem. For example, if we start with 50 items from original questionnaire and we have deleted 25 items and we are saying that that model is working properly, then we should throw away this model, because almost half of the items are gone in that situation, and this is a serious matter. So we need to understand one thing, that we can only delete 20% of our items. In this example, let's say we have 50 items and 20% of 50 mean we can only delete up to 10 items. So anything more than that, we can no longer conformity, or we are no longer in conformity, we are actually back to exploratory. But if we are doing this in PLS, from the start, arrow terms already correlated like this one. We don't modify it later. That's why in PLS we don't see this. It only shows us items. They are actually correlated. That's why sample size in PLS can be smaller than sample size in covariance based SEM, because we don't have to estimate this. If you see in this model, in the common factor analysis, here we have to estimate 1, 2, 3, 4, 5, 6, 7, 8 and 9 parameters. While if you see in this model, in the composite factor, they are already correlated and we don't have to estimate them. We only have to estimate 1, 2, 3 and 4. And if we put same model in the common factors, again we have to estimate only 4 parameters in the composite, and if we add 3 in the common factor analysis, then we have to estimate the 7th one. So if we compare both of the model, in this model we have to estimate only 4, while here we have to estimate 9. So 4 versus 9, 9 required a bigger sample size, 4 required small sample size. That's why PLS works with the smaller number. Now there are few questions or few queries we have to answer. The number one, what does it mean correlated? Now if you see, all these items are composite measure of this variable, while if you see over here, these are the causal measure, mean these 4 items must be highly correlated with that particular construct, and items must be highly correlated. When we do something like this, loadings are low because we didn't correlate the error terms. But if we correlate error terms like this, loading will go up. That's why in PLS we don't end up deleting more items, while in EMOS we end up deleting the items. Now another question is that what option or which process we should process. It depends on these two basic things: CB-SEM, covariance based SEM, pls-sem, variance based SEM. Now it depends that if we are going to confirm the theory, then CB-SEM is a better choice. And if we are going to develop the theory, then pls-sem is a better option. What does it mean developing the theory? That's mean originally theory has only 3 independent variable and 1 dependent variable. So what we will do, we will add one another new variable. That's called developing the theory. And pls-sem, this is called exploratory modeling, while CB-SEM, this is known as conformity modeling. So what process we have to follow, that depends on that particular two situations.